Welcome to Vintage Radio Cafe, your #1 channel for relaxing vintage audio restoration. If you like watching an idiot wielding a soldering iron, you've come to the right place. Watch Ray's attempts to fix wonderful forgotten radios from another era, way before transistors. Sometimes he even gets them working again. What could go wrong, right?
So day 11, working on the radio, working on this Blaupunkt 2540. I'm just about to remove this board, and after thinking about it long and hard, I decided I'm going to cut the wires, all those wires. So I'm making this video so I remember how to put it back exactly how it was. I thought I was going to get away with just unsoldering this one, but as expected, it goes in deep through this through this connector here. It goes on the other side of the chassis, so I tried unsoldering it and I resoldered it. I put some new solder on it, and I am going to cut it instead. I have to be mindful about this one here, yellow or beige, whatever, used to be white maybe, because I don't have much room. Then this brown wire, this yellow, this is truly yellow, this green one, and black and red here, and another yellow. So all this I'll have to cut. The problem is I tried to unsolder from here directly, this little board, but they go inside so, they're so stiff. The amount of heat needed just to break this loose, and it's soldered on the other side too, a bunch of solder here. The amount of heat needed is surely going to break those resistors. They're going to crack under heat, and yeah, just to be safe, I bought a bunch of, I'm sorry, I cut the video instead of zooming in. So I bought a bunch of resistors, all the right values, and then some extras I might need later on. So you know me, if you've seen any of my videos before. I don't like to work on something I don't have the new parts in my hands ahead of time before I start. So that's the idea, that's the plan for today. I'll be back once I'm done, and wish me luck. This is going to be hard. And here's the result. After recapping this board, I ended up using a quick disconnect all over, simply because it was easier than desoldering directly on contacts or on the board. But also the wires were too short to reconnect them, so I would have had to put some longer cables and do more connections, so I figured it would be easier this way. I've put just a temporary, very loosely fitted tie wrap just to keep everything clean, but if I find it induces noise, I'll just make the just take it off, make the wires loose and separate them again. While I was there, I changed a couple of low value caps, which were over 30% off. The whole radio, actually, every single cap was higher, between 30 and 52% higher, namely the big filter caps, the electrolytics, namely those. I tested it, and it's everything worked, nothing exploded, nothing shorted out. It works as it was working before, but still the same problem. It doesn't tune more than, I'd say, 55-60% on each stations, whether it be AM or FM, and the FM is pretty weak. And I checked all the resistors this morning, and I couldn't find one single one of them out of spec or open. A few were a little bit higher, but nothing that could cause this kind of issue, especially not around the FM can here. I checked on the other side. There's also resistors, 3 little caps. Everything looks good. I even unsoldered this one and went to look under the shroud there to test that little capacitor, and it was perfect. So next thing will be to replace the rectifier, which we can't see now. No. Anyways, you've seen the rectifier before. I also checked all the voltages on the tube sockets, and it's all over the place. Some are higher, some are closer. They might be inverted here. Sorry. Some are closer, some are a little bit off, but the worst one is really on the FM tube, the ECC85, as you can see. On pin 6, got 199, should be 115. And which other one? I didn't write them. Anyways, they're all higher. Here on the grid, it should be a negative voltage. At least it's negative at minus 0.5 volt, but it should be minus 2.5 volts. So I'm guessing here that once the voltage is correct from the rectifier, this should improve. Not to say it's going to be perfect, but it should improve. So on that, I ordered some rectifier boards designed by Manuel Caldeira. I heard great things about them. I've seen him use them. So they're really nicely made. The round one is for putting new filter caps in. I'll be using the one on the left, which will replace exactly the rectifier that I have. As you can see, it's a bridge rectifier, and you just put your own diodes in. And what I like is all the resistors are in series. So you can put one, test it, put another one, test it, and I'll have to do some calculations once I have a better idea of what is going to be the voltage drop with silicone instead of selenium. I'm not surprised I have to change the selenium rectifier, but it's going to be my first attempt at this. So while I'm waiting for that, I guess I'll be working on the speakers, especially the electrostatic tweeters. I'm not getting anything out of it. There's 4 caps on the whole speaker array, and I'll change those first, but I'm sure it won't make any difference. Once the tweeters, the actual foam that makes the pressure on the 2 plates, once that is dried up and all crushed, there's no contact anymore. So no matter what voltage you send there and how much you filter it, if the contact is not good, you're not going to get any sound. Not that I expect them to be as good as modern tweeters. They still produce very high pitched sound, and it should make a difference, but it's usually not very powerful. But we'll see when I get to that. So catch you in the next episode. Hello guys, welcome back. So it's the end of the 11th day 11, working on the radio. And today I did the recapping of the speaker. There was 4 capacitors to replace. One of them, the 4 microfarad electrolytic, was completely dead. I mean, I had no reading at all whatsoever. So I replaced all 4 of them. I tested the radio, and as expected, the electrostatic tweeters weren't working. So I took it apart. Took one apart. So this is the back plate when it's in the radio. It's like this. It goes over the grill, the metal grill, and it sits in the front of the radio. And I want to show you why. If you've never seen an electrostatic tweeter, I want to show you how it's made and why it stops working. It was different on the Grundig. On the Grundig, the way it's made, there's the metal grill, and there's this little copper sheet, very, very thin sheet of copper that's supposed to make contact with this part. This part sits just between the grill. I'll try to show you where it goes. Sits like this. And once it's glued, actually it's just a thin film of some kind of polymer or plastic. It resembles a bag of chips, actually. And this part is just plastic, and this part is covered with a thin, even thinner coat of copper or something conductive. And once the sponge is there and it makes pressure, and both are in contact all the time, so with the proper voltage and current, it vibrates and gives the high frequency. The problem is, with time, those two are not glued together. So there's always a bit of movement, and with time and oxygen in the air, it gets oxidized. So I don't know if you can see. I'll try flashing a light. Maybe from the back you'll see there's no more metal where the sheet of metal was. So you can see there's no more metal there. Let me move in closer just to make super sure you see it. Yeah, so you can see through it. So there's no more metal there, so there's no contact. So what I'm attempting to do, I deoxidize everything. I don't need this anymore. I deox the metal sheet here, and this one first with 75% alcohol, and then with some deoxit, very, very gently. And I'll show you the difference. It's supposed to be conductive, okay? So let's test it with the multimeter. If I touch the metal part and I touch here, see, there's no metal. If I go on the metal part, so it's impossible for the device to work. So what I'm attempting to do now is find a good part of metal and just refit this one here. Try to glue it gently where it's supposed to go. Yeah, something like that. And when I put the foam, the sponge, back in place, it should make contact now. Now the other problem I have is, try to move in closer. Maybe you can see it here. The metal is the sheet of metal is almost broken. There's still continuity, but it's almost broken. And it doesn't seem to be sitting on a tab or anything. So I think there's metal missing, and it was supposed to make contact here, I think. So anyways, you get the idea. Re-glue this in place and hopefully have a working electrostatic speaker after. Now, I just want to make it clear, the way you remove this is so old. Actually, I think only the round part, which is a little bit, there's a little bit more plastic. There's like 1 or 2 millimeters more plastic. Sorry, more plastic here, and there was just a little bit of glue, like Scotch tape, if you will, and it's stuck there. But with time, it's really it's not sticking anymore, except for that part. And you cannot just rip it apart. It breaks too easily. So what I did was, again, take some alcohol on a cotton swab and go from the other side, and I just flooded this part and waited a couple of minutes until it sort of not melted, but it rendered the bit of glue that was left inactive. So I'll have to put this in place as best as I can. Doesn't have to be perfectly centered, I wouldn't think. As long as there's a part of metal that's making contact. And just beneath, there's some Scotch tape there. So there's actually only about this part that's going to make contact. Anyways, you get the idea. It's late at night. I'll still try to finish this before going to bed and test it. And if it works, I'll tackle the other one tomorrow morning. And don't use heat, like I said. A bit of alcohol if you have to do it. And I'll have to clean the actual, this is phenolic plate, and there's only 2 contacts. One is actually one of the tabs was sticking out, and there was a wire soldered to it. I forget which one. It was this one. So there has to be contact with this from this part, and the other contact was just here. And you have to fish the tabs through those holes back again. It's really, the principle is simple, but after 65 years, 66 years in this case, you cannot make new stuff with old stuff. I'll do the best I can. And all this knowing full well that it'll never be like modern tweeters. It won't give much volume, but might be a presence, a little bit of a high tones, maybe give a little bit of clarity. I also want to clean this contact. I did clean it, but I'm going to use Brasso inside and out and try to make it shiny and get a better contact as good as I can. Anyways, so I'll do this off camera, of course, and I'll come back tomorrow and show you the results. If it works, I'll tackle the other one. So have a good night. Okay, welcome back, everybody. It's around noon on the 12th day. The 12th day working on the radio. Yesterday I worked most of the day on the electrostatic tweeters. I did the best I could, and they don't seem to be working. Maybe there's a little bit of sound, very high pitch sound, high frequency coming out from one of them, if you have enough imagination, and the other one is certainly dead. So I reached out to a fellow radio restorer that I recently discovered on Marketplace, and he's going to be looking at his stock. Maybe he has replacements for me. If not, I'll live with it. I mean, the sound with the full range mid-range speakers on each side, I've got more than enough high frequency sound. So we'll see when I get if I get new old stock electrostatic tweeters. So for today, what I did last night was just to take out the original Selenium rectifier, and I got the new boards in that are designed, made by PCBWay, but designed by Manuel Caldeira. And I've already put in the diodes in them on the board. And the way this works is you absolutely have to put a resistor, because the voltage drop on the Selenium is much higher than what we'll have with silicone. So the voltage coming from the transformer will be outputted as DC, but much more than likely will be much higher here. So the target voltage DC that I need from the rectifier is 278 volts on the AM and 270, I believe, on the FM. Right now I'm getting like 250 and 240, 252 to 240, 239, something like that. So the difference is correct, but the voltage is too low, probably because these guys are just tired, they're just weak. And that's why you need a at least one resistor that is going to bring that voltage down. Since the circuit itself doesn't bring the voltage down as much, well, after those, that's the job of the resistors. And they are set up in parallel. So this means if I need more than one, and I most likely will, when you do the calculation, I'll need like a current or the wattage will be at least 3 watts if I have to drop 30 volts, more if I have to drop more voltage, like 40. I'm guessing I'm going to be around 30, but it's guesswork now. So the first test we do, this is going to be my tester. If I mess something up, I have more boards. So the idea is to just solder a lead or wire or something to make the contacts here, to make sure the circuit is complete, and to do a first test on the dim bulb tester and see what kind of voltage we get. So it's going to be restricted by the dim bulb, and I'll lower the voltage to start my tests. And we move forward from that point on until we get to make at least one short test, unrestricted, full power, to have an idea how many volts we have to drop. And then we'll do some calculations and figure out just how many resistors we need and what will be their value. It's not the same thing to calculate the resistor's value in series than in parallel. There's a formula. It's not complex, but you just have to really look at your circuit and determine from the get-go if it's going to be if the resistor is going to be in series and parallel. So that's the intended end result. And what we start with, this little can, there's well, you have to open it, and the way to do that is you really have to unbend the sides. You can use a screwdriver. I didn't like the result. It was denting, all over. So I started a corner on each with a small screwdriver, and I ended up using a scraper. It was the right size, the right length, and I could just insert it and fold it back just enough to be able to remove the parts. So I'll try to, everything's going to pop out most likely, but just want to show you how it's built. Just trying to prevent the contacts from popping out. So that's one side. This is the other side. So you remove the cover, and the contacts were like that, and all the selenium plates. That's one side, that's the other side, and it's all made because there's just a little bit of a folded flange here, so it hooks up where it's supposed to be, and it sits there. And the contacts are here, which we're not going to be using because we're going to be soldering directly on the same points. So when it was in, the two AC coming in were top left, bottom right, and top right and bottom left was the DC coming out, plus and minus. I don't know if you can see that. That's how it works. And the board is made exactly the same way, with the AC top left, bottom right, and the DC top right, bottom left. Easy enough. Just have to remember that the diodes go on top of this whole assembly, and the idea is to remove everything. I don't even have to go this slow. I'm not going to be reusing those. It's all going to the garbage. But just want to show you so you have an idea how it's built. All those plates are selenium instead of silicone. That's why we have different output, actually, because the voltage drop is quite different. Drops a lot more voltage. There you go. So this is what we're left with, and we have to somehow, if we can't, reuse this to mount the board on. Fits perfectly. Yeah. Both holes. Although not sure if it's going to fit. I'll find a way. The beauty of Manuel's boards are the pads, and they're usable on both sides. So when you're trying to figure out what's the resistor value, well, you can make tests. You can try them different combination, and you can solder from the top, not just the bottom. See what I mean? So that's what I'm going to be working on today. Hope it works. So let me turn you guys. Yeah. So is there yeah, there's a shield here. That's nice. Probably to prevent contact directly from the components to the can, I would imagine. But that's the idea. So once I'm done, I'll do this off camera because it's going to take me a long time. But once I'm done, I'll come and show you the results. Okay, welcome back. Day 13 working on the Blaupunkt radio. And this is what I've done so far. I rebuilt the rectifier with silicone diodes, and after testing, making a first test without any resistors, just a wire to make the link between the array of diodes to the rest of the board, I measured 300 volts. So the target is 278 FM and AM and 270 FM. So I needed to drop 20 volts, but all that I could find were 680 ohms resistors, which are a bit too high, and it got me about halfway. It got me to maybe 15 volts, something like that, higher than what I was having before. So the highest voltage that I got was about 265 and 256, I believe, for FM. So we're still too low. That was the first problem, but it was just, to make a test, preliminary test. Second problem is those are 2 waters. And since now I know that I only need to drop 20 volts, so I need only 2 watts of current capacity, actually. And so this is too high. They're all 2 watts, so that's 6. But 6 watts instead of 2, well, it's not a bad thing, But they're so big, I couldn't use the original can. I couldn't close it. On the same subject, this is the original frame that was inside the original rectifier, and it's too big and at the same time too small. It's too big because it's too high, so there's nothing I can do with it. I could use a Dremel and take all the inner plastic out, but it wouldn't leave me enough plastic. I wouldn't have much of a frame left. I wouldn't have anything left. So this goes back in the Blaupunkt rectifier parts, if I ever need them for something else. This one will remain my tester, but it won't go in the radio anymore. And this is the new one I did with the 600 ohms resistors, 1 watt. So it'll give me 3 watts. So I'll have 1 watt of headroom. I'll have 1 extra watt. I only need 2. I'll have 3, so I'll be safe. And it should get me 20 volts lower than 300 volts. So I should be around 280 in theory. So that's the plan for this part of the day. Then after that, I'll show you what's the next part. I did some more tests and I made interesting finds. So instead of using a plastic frame, what I did, I used little spacers, which I had to cut by hand. Which I had to cut by hand and then sand them down to bring them down as much as I could, but still remaining enough space for the board not to touch. And instead of a frame, I put some foam, double-sided stick-up foam, and all this allows the board to float, so it won't be touching the base at all. And on top of that, there's already insulation here, and I insulated the back with some tape, and it will allow me now to refit the top insulator. It'll be a bit of a tight fit, but not much. It's actually perfect. And I double checked, and there's nothing at the base that's touching. There's air. There'll be circulation, just enough. And this plate, instead of I could fit it. I could crush it, inside. But instead of doing that, as there's no point. It's going to sit on top. With the screws, it's not going to go anywhere. So lastly, what I also did is I isolated the whole can just to make certain. Why? Well, because since the wires are going to be connected directly to the board, they won't be sticking out as much as the previous connectors that was on the can. That would stick out more like that. I could put just a bit of wire and make my connections higher, which I might do, but I don't think there will be a problem there. There's nothing that should be touching. When I do my connections, I just have to be mindful not to allow them to protrude on the back side, you know, to make them as flush as possible with this solder. And hopefully this will work. And once I'm going to be doing this one, I don't plan on taking it out again. So I want to be, well, it's a calculated risk because I did the math, and I know the voltage should be okay. And so I'm going to put it pretty much permanently now. So I'll do this off camera and come back to show you the results. Okay, welcome back. So day 14 working on the radio. Last time I did a video, I was talking about maybe having something concerning the resistors because of the higher voltage I was getting on the on most of the tubes, but basically most importantly on the ECC85 for the FM, which I thought, you know, would be the cause of not getting super great tuning on the FM band. Then again, the AM, although has a louder output, doesn't tune 100%. So to make a long story short, I've been 2, maybe 3 days checking all the resistors, and whenever I thought one was low or maybe shorted, I looked at the schematic and determined if it was connected to something else that would modify my readings, or if it was connected in parallel with a coil, which would make basically the resistor disappear. And even if I did that, well, anytime I pulled a resistor out, once I had it in my hand, once I had one leg pulled out, unsoldered, and I tested it, it was great. It was always perfect. Aside from 2 little ones I changed, they're all good. So unless I misread, you know, I made a major mistake, all the resistors are okay. So the next step, I guess, is to try to do an alignment. At least the IF, since I'm getting about the same result, well, after I put in the dial back, I could see that all the stations are off. They're off by, I don't know, 20%, 15% off, all on the same side. It's possible the pointer is moved, but it's very, very, very solid. It's unlikely it moved at all on the cord, but the cord might have stretched. Although, if it would have been the case, since there's a pointer on top and one at the bottom, logically, if the string stretched, one would have moved on one side and the other one on the other side. So basically, I'm thinking the radio needs an IF alignment, which I would have done anyways. Even if it would have been perfect, I would have checked it. So to do an alignment, you need, of course, a signal generator. And this one, it's the only one I have. It's for AM and it's analog. So whenever you turn the dial, you don't really know what frequency you're at. So for that, I hook up a frequency counter, and as you can see, the IF frequency on this radio is 460, so I'm very, very close. And you let everything warm up so it stabilizes. And to measure the result, well, you have to go and put a VTVM, you know, a vacuum tube voltmeter across. Those are the green and yellow alligator clips across the terminals of this speaker, and you will see the result, the deflection here on the VTVM. Simple enough in theory, you know. You just have to use one of those and just, you know, turn all the lugs following the procedure, and you should see deflection on the needle there. But they are, all the lugs, all the screws are really stuck. They're tight. So I put a little bit, I mean a really tiny bit of WD-40 to try to loosen them up. And I tried them with a screwdriver this morning without any power on, and they were turning. They're hard to turn, they were turning. The issue I have is they both, all of them have two lugs to adjust. One from the top, one from the bottom. So I'll have to turn the radio around and find a position where I can do everything without moving the radio after that, because there's so many wires, as you can see. In my case, since I have to hook up the signal gen to the frequency counter, I came up with this solution last year. It's a little board, and I put just two wires where I can hook up both the grounds and the signal from the signal generator, and try to show you here, and hook it up to the frequency counter. From there, there's two more wires. There's one ground and this red one, this red one that goes underneath the chassis. That's the other concern. To access the grid of the mixer, the ECC81, well, it's this guy here and those miniature, yeah, that one. Those guys don't have a grid cap. So the grid is only accessible from its pin, number 2 pin underneath. And you don't see the pins on this design, since it's, all the sockets are on a PCB board, or an ancestor of the PCB that we know today. All the pins are covered in a river of solder. But they did take the time to add a little pin next to it at the bottom. So there's a pin, maybe 1/4 of an inch tall. And this pin goes directly to pin number 2, which is the control grid number 1, which I need to inject the signal to. But your signal generator cannot go directly to that pin. You need to use one of those little 0.01 microfarad capacitors. So that has been soldered lightly to said pin, and that red wire goes to that. So pretty complex setup. And I'll just turn on the radio and show you that we are getting the signal. So AM, we're on full power now. Radio is going to warm up. Capacitors are going to charge up. Filaments are going to warm the tubes. And I'm already hearing the tone. So let me just put the volume on. And as you can see on the meter, just touching the volume, you can see the needle deflecting. So the idea is to turn the lugs in the right order follow the procedure and try to peak every one of them. And the procedure is here. Thank you to David Tipton, who actually found the right document, the right schematic, because both ones I had, the two I had, they weren't for that specific radio. This is really for the USA model, and I have the right values, because the other ones I had 460 and the other one was at 455, so I didn't know what was the actual intermediate frequency, and with this one I know it's 460. So I'll follow the procedure, start with the IF alignment, and then as we go along, antenna socket, this is the RF, and you have to move back and forth to different frequencies. But first things first, the IF. So this one, as you can see, is really the Blaupunkt Super Riviera 2540 USA. So I know all the numbers there are correct for my radio, and what I'm talking about, just let me put the volume down. I'm sorry, I don't hear this anymore. So when I say they have two lugs, or they all marked here, L718 at the top, and at the bottom 719, 725, 26, so on and so forth. So I have to start with the right ones in the right order. So the first one will be 732 and 731. So those guys, 31, 32. So you're looking at the chassis from the back. So it's the can the most to the right. So it's going to be this guy here, and I marked every one of them on the top and on the side. So once I move the radio, I know what I'm doing and which of the coils I'm adjusting. Maybe nothing will change. Maybe everything is peaked at the moment. I have no idea. I'll find out as I go along. I'll start with trying to turn the radio so I can access everything in one operation, and I'll get back to you once it's done. I'll do it off camera.
Beaucoup de gens qui ont commenté ces tenues vestimentaires là, pendant les journées où la convention démocrate a eu lieu, et bon, il faisait référence à des lecteurs de la presse qui avaient critiqué le fait qu'on est encore en train de décrire les tenues vestimentaires des femmes. Puis Richard, et tu poses une question quand même que je trouve intéressante. Il se demande, est-ce que la description de l'apparence de Kamala Harris...
About the graphics. I'm probably the only person or father to hear this from the on-deck circle was, "Come on, Dad." Father has a basic sense of the play. This is history. Oh no, don't talk about that. I don't want to talk about that. That just grounded him. You want me to talk about him getting grounded, don't you? When I first got in the outfield, I said, I'm going to cover 3 square feet and the rest is yours. I started ducking because I didn't know where the ball was. So I was going to get hit in the head. I didn't think it was funny. So what I did was I jogged off the field, got into the dugout, and I said, come here. I said, you're grounded. And I took the car keys from him.
D'accord, c'est un bleu marin, un noir. Gris. Ouais. Exactement. Donc, la cravate fait un peu la différence. Est-ce que tu veux mettre une cravate qui est la couleur de ton option politique? Donc, si tu es libéral, une cravate rouge. Si tu es péquiste, tu mets une cravate bleue. Ce genre de questions.
Okay, guys. So, it's the end of the 14th day. I just wanted to round up my day. I spent all day trying to align the radio, both on the IF and the RF. To no avail, because it was spot on. It was perfect. I mean, maybe I tweaked a little bit some of the inductors, the coils there, capacitors, maybe a little tiny bit, but you know, they were exactly where they should have been. They were all peaked. And after all that, I put the radio back together and decided that I'm calling it done. As you heard it, it sounds very good. Oddly enough, the FM is not as weak now. Maybe it has to do with the fact that I cleaned I did another pass on the FM switch from the bottom. Maybe it's that. Maybe it's just that some of I don't want to say dust. It's certainly not corrosion, but it might have been still something there. And the more I play, the more the radio plays, the better it sounds. And I can tell you it sounds even better upstairs on the first floor, because here I'm in the basement and the reception is not as good. And I get a little bit of hum. But now, as it stands, I can tell you it sounds good, it looks good, and it smells good. You know how that was important for me. And let me show you just what such a restoration entails in terms of parts. There you have it. There's more tubes there. There's more vacuum tubes that what I actually changed, because there's only 9 in that set. But I still had to check other ones that I had already. Some were not working, so I had to test that. All of those, I mean. And what's involved is replacing 9 tubes, 32 caps. Doesn't show like that, but there's 32 caps if you count the 2 main filter electrolytics. Change the light bulbs, 3 resistors here, all the paper caps. Obviously, well, you witnessed everything, so you know what I did. I rebuilt the rectifier also. Those are the leftover parts. I cleaned and repainted it, of course. It was 14 days of work, spanned over 5 weeks, because I had to wait for components, for the vacuum tubes and the capacitors. Oddly enough, I'm going to remember this. I got it at my birthday on July 12th. It was a gift from me to me with love. And I finished it on August 19. Now, August 19 is my little sister's birthday. So I'm not going to forget those dates. I paid $100 for the radio. Again, you know the story. There's more than $350 worth of components inside. The tubes alone cost me $200. Then all the electrolytics and caps and resistors. You always buy more, of course. You buy 2 or 3 times the amount you need, just in case. So I'll have some leftover caps for the next project. What is it worth now? Well, I've got $450 into it. The scammer, the fraudulent imaginary seller was asking for $600 for it. Well, I can tell you now, it is worth $600 as it stands now, and maybe more, depending on how badly somebody wants it. My radios are usually not for sale, so I'm going to keep it, but I'm just trying to point out what's the value of repairing them yourself. Many people sell those radios, especially the German ones, because they heard of their great reputation and how good they sound. They ask astronomical amount of money for radios that are either not working, or they say they're working, but you've got the perfect example here. Yeah, I suppose if I would have changed a couple of tubes, I would have gotten sound out of it, but it never sounds as good as when you recap it completely. And people ask that amount of money because they think they're going to get rich overnight on Marketplace, or they really believe that that's what it's worth, they are worth, and that they're easily fixed, which is not the case. It's not easy to work on a German radio, but it's well worth it. I can tell you that. It was a really, really fun project. I really loved working on it. I'm proud to own this radio. And like I said, it works better upstairs on the main floor. But even here, it sounds very, very good. And I actually did a little footage upstairs, which I'm going to add to this this final episode, just to show you, because I don't want to take a chance here and hit some music and get flagged. I don't want that. I'm starting my YouTube channel, so I don't want to start on strikes. So everybody that was you know, that stayed with me for the 14 days I worked on the radio, thank you very much. Please like, share, and subscribe. It would help me out to start. And if at all possible, and I get many subscribers one day, well, I'll be able to buy more equipment and do more of those radios. So thank you very, very much. Have a great day, everybody.
C'est exactement ce que les citoyens qui allaient aux consultations publiques craignaient et que votre administration ne voulait pas entendre.
C'est pas qu'on voulait pas entendre, c'est qu'on avait une expérience avec la maison de Noël qui datait de 2019 dans son...
And while students here in Montreal had to deal with a bus strike last year, students in Kentucky find themselves starting the school year without a bus at all because their route was eliminated. The Jefferson County School District decided to reduce the number of routes. 43 schools impacted by the cuts. Decision has led to numerous protests, complaints, a lawsuit, and now one heck of a music video. Students known as the Real Young Prodigies produced a protest song called Where My Bus At.
Where my bus at? Where my bus at? I need transportation to go where my bus at.
Look, where's my bus? I'm trying to get to my destination.
Jumping a bar and hesitating. Been up since 5 and I'm done with waiting. I need a lift.
Now, you might not believe it, but this song is completely produced and written by elementary and high school students.
It's my new jam.
There's a music video on YouTube. They got a little bit of help from a production company for that. But the song is entirely student-made. School district says, yeah, well, if more bus drivers become available, it may be able to turn busing to some schools. But